Okay. Good afternoon, everyone. Can you please confirm if you can hear me? Can you all please confirm if you can hear me? Let me create a poll.
Hello, everyone. Yeah, there is a poll question, I think, from Enoch. Yep. Enoch, are you there? Are
I
you able
can
to
hear
hear
you,
me?
Bernie. Over to you.
Yeah, wonderful. Yeah. I was on another call, sorry. I think a lot of people have to join in, right? Enoch, roughly 250 people have to join. Only 110 have joined. So why don't you ask our friends to join our Facebook group, because we are posting a lot of articles on that, right? They can probably read. A few of them seems like they do not have access to LinkedIn.
All right,
Yeah.
do that.
Yeah, you might want to
So,
share.
sure. So, guys, I'm sharing. I'm going to put a sticky note here. Before that, let me just share my screen. So, this is our Facebook group, guys, and this what happens is all the events that we have. Give me a second. All the events that we currently have, every single event, be it within the AI space or be it in the data science or big data, all the all the information about these events we constantly keep putting in this group, and there will be other people, other like-minded people in the group. So if you have any questions, you can just ask this group. So this is like a really good community, and we'll be posting really new uh, uh, really interesting articles within the group. So let me quickly share this in the chat as well. Please go ahead, and once you are within the group, you will be able to click on a button which says join. And once you click that button, I'll be able to approve you guys from the backend. So please confirm once you have joined the group, guys. I've shared you the link. Please give me a confirmation once you have joined it. So let me see how many of you have requested to join the group. I can see only 22 requests, and I believe we are about 130 people right now. And that means we still have about maybe 100 people more, maybe 100 to 110 people more. So go ahead, guys. I'm going to share the link again. Please join the group, and inside the group, you can interact with each other. It is like a community of all the data scientists. So I believe we have roughly about 6,000 people within the group, and I'm pretty sure you'll find a lot of value in the group. And at any point, let's say you're doing your project and you're stuck somewhere and you need some help, you can just come over to the group and just ask someone, post some screenshots, and there'll be people willing to help you out. So let me check it once again. I believe so far about 60 people have joined, but there's still a lot many yet to join. So I believe there's 143 people, and that means almost 80 people have not joined yet. So once again, guys, this is a group that we have created to build a community around the data science uh, working professionals or data science enthusiasts and students. So within the group, what happens is, so if you can see, we have about 6,700 people, and every single person out of the 6,700 is actually interested in data science. And so at any point, let's say you let's say you're studying something, and let's say you have a question, you can just come over here, post your question, and one or the other out of the 6,000 people will help you out. So let me see if any new people have wanted to join. So we got 9. There's still a lot of you who are yet to. So Syed Bashir, let me share you the link. So the link is in the comments. So just open the link. For those of you who don't have Facebook, tomorrow we'll be giving you the link for giving you the same similar thing but in LinkedIn. So we got you covered. Don't worry. So let me quickly approve all of you who have requested. All right, looks like there's about 14 more people who've requested. All right, let me ask a quick question. Or how many of you have not yet subscribed to our YouTube channel, guys? Your session recordings would be on YouTube. So it is very important that you sign up to our YouTube channel or you subscribe to our channel, because the playlist is a private playlist, which means it is not available for the public. And you need to subscribe so that you can get access to it, and also so that whenever we upload a new video, it will just come off. It will just show up there. It's fine, Sri Lakshmi. All right, so let's look at. So this is our YouTube playlist, and we have day 2 video. Day 3 video would be here by the end of your session, and all you need to do is click on subscribe. Perfect. Just like that, you're subscribed. And
Sure.
one, yeah.
So what we shall do is I'll just get started,
Sure.
and after 1 hour, maybe there'll be another 100 odd people who might join, and then we can, you know, share the details. And any luck on the day 1 thing from the webinar jam team? No.
Not yet, Bernie.
Okay, no problem. Yeah. Shalom.
Yeah. Over to
All
you.
right. Yeah. Thank you. Thank you so much, Enoch. So let me open the slides that I've. Okay. I think slides are not needed any which ways. So. Okay. Hello, everyone, and welcome to the session. And please confirm on whether you're able to hear me or not. I'll do a quick poll here. Are you able to hear me? Yes or a no? Can you please respond? Wonderful. So all of you are able to hear me. Perfect. So let us continue on where we have left yesterday. We started off by discussing about artificial intelligence. Yesterday's part was all about artificial intelligence, right? So what did we do there? What did we learn? Let's get to those finer nuances. We have yesterday discussed about artificial neural network, which is also called as multi-layered perceptron. But before that, we discussed about perceptron algorithm. And we also had this discussion on perceptron algorithm handling linearly separable boundaries. Okay, linearly separable boundaries is what perceptron algorithm can handle. Multi-layered perceptron can handle non-linear boundaries. When it comes to perceptron algorithm, you will have the input layer and a neuron. That's it. So you have three inputs, x1, x2, x3, and you'll also have a bias, which will always have an input one. And all these will have weights. Weights are randomly assigned. And then you have an output. And here, within the neuron, you'll have two components. What are those? Integration component and activation component. You'll have two components. One is the integration component, another is your activation component. And then you have an output. When you don't have any hidden layers, it's called as perceptron algorithm. Simple. And ANN or MLP, which is nonlinear boundary, say you have input layer, okay, and then you might have hidden layers, and then you have your output layer. If every neuron, if every neuron is connected to every other neuron, then this network is also called as dense network. It's very dense because all the neurons are connected to all the other neurons. So it is kind of dense network. Number of hidden layers and number of hidden neurons that you want to have, number of hidden layers and number of hidden neurons you want to have depends on you, basically. It depends on data scientists or AI experts. They can analyze, they can experiment with as many number of neurons as possible and as many number of hidden layers as possible. And each hidden layer would have summation and activation, summation and activation, summation and activation. Yep, each one will have integration, activation. And then finally you have an output. Since initially weights are randomly assigned, once you come forward and calculate your output or predict your output, you go back. Okay, you go back and update your weights. When you go back and update your weights will get updated to reduce your error. Okay, to reduce the error. And then again you come forward, calculate the predicted value, compare it with the actual value. If there is error, again go back and update the weights. This algorithm is called as back propagation algorithm. And this back propagation algorithm is used to update your weights. It is used to update your weights. So what we shall now do is we will take MLP and then we'll try to solve that. Okay, we'll solve it using R first. So what we shall do is I'll go to R. Then we are going to run this code. Just give me a minute while I try to get the data. Mm, just give me a minute while I try to pull up that data. If it's not there, I need to get to my pen drive and then I need to get the right file so that, yeah, it's here, but then we need the data also. I thought it was there. Sorry, my bad. I can pick up. There is another file which I can pick up, but then, no, I want to get right document out. Not this one, this one. This has neural network stuff. Yeah, hopefully this. Yep. But then I need to get concrete data set. Yep. Let me do that. Let me pull up that data while yep, it's there in this pen drive somewhere. So I'll go here. This is AI session. So I'll copy it here. Let me also save this so that I might share it with you all. Hmm. I'm gonna save this here. AI multi-layered perceptron. Okay. So I assume or I understand that a lot of you all do not have knowledge on R programming or Python programming. While it is going to be slightly challenging for me to, help you guys understand these concepts, I mean, programming aspects, I'll try my best. Okay. And one more thing, we are planning to have a free Python session and free R programming session. And you can all, on tomorrow, I'm going to explain that. And uh, ideally, this session was for 6 days, but we want to confine it to, 5 days because we were expecting, we'll let you know tomorrow, Sri Lakshmi, on that. We were expecting close to 1,000 odd people, but then only less than 200 people have joined. So that means not many people would be notified or they are not interested, seems like. So, yeah, we also need to look into our efforts which are going into this. So we'll confine that. And for Python training, we will let you know tomorrow on when we are going to have that session. And for each and every college, we are going to give the link provided there are at least 500 students who join in. I will be personally investing my time on training people on R programming session first and then Python programming later. Okay, tomorrow we will get it ready and then we will publish the details for you. Now, let me explain. I'll try my best. I'll try my best, okay, to help you guys understand this because you don't have programming knowledge, okay? So don't worry about what is given here. If you feel it's overwhelming, threatening with respect to the program, the moment you look at that code, you might feel, oh my God, such a lengthy program. Don't worry. R or Python is as simple as English language. Okay, I'll try my best to explain here. I'll try my best to explain. If you do a drop down here, import dataset, and if you go to from text reader, click on that, and if you try to browse, then here, if you see, we have concrete data. Okay, 1 second, sorry. All right, so sorry. Hmm. Just give me a minute. Extremely sorry about that. Just give me a minute. Extremely sorry, friends. Just give me a minute. One second. All right. So, so it's very, very simple to import datasets into R. You just need to click on import dataset. You can choose this or this. There are two options available. So I'm choosing this option from text reader. And then it will ask you to browse and then find the file which you want to load. Say I want to import this dataset called concrete. I click on open. It's going to show me how many variables are there in the dataset, how many rows are there in the dataset, right? And then if I click on import, you get to see the data. Okay, and then let me explain about this dataset here, which got imported. So this is the name of the file, concrete. If you see concrete, and it has 9 variables and 1030 observations. So you have these many rows and you have 9 columns. You have 9 columns and 1030 rows or observations. When you import using this option, you give reader, library of reader, and then you have a function called read underscore CSV. And within the double quotes, you give the complete name of the file along a complete path of the file where you have stored the data and the name of the file and extension. And whatever you see here, this less than and minus sign, less than and minus sign that you're seeing here is called as assignment operator. Is called as assignment operator. And using this assignment operator, you're assigning this data set to an object called concrete. Okay, we have an object called concrete. And when you say view concrete, V in caps, view of concrete wherein V in caps, then you see this data set which pops up here. And this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 columns. In these 9 columns, we want to predict the output, which is strength. What is the strength of the concrete? And you have various inputs, x1, x2, x3, x4, x5, x6, x7, x8. Given all these 8 inputs, we need to predict the output, which is the strength. Yeah, given all these 8 inputs, we need to predict the strength, which is the output variable. I mean, I'm sure you all are aware of various high-rise buildings which are being constructed. And if you look at Saudi Arabia, we have in Saudi Arabia something called as Kingdom Tower. Kingdom Tower. Okay. And This Kingdom Tower is 1 kilometer high building. 1 kilometer high. It's under construction still. It's gonna take some more time, a few years, given this economic turmoil. At 1 kilometer high, what will be the speed of the wind? And will your concrete structure withstand the wind or not? That is what we want to know. Right, so that is what we have. Someone is asking me on, can I maximize the font size? Dr. Parthasarathi. It's the same link, Dr. Parthasarathi. What is the confusion here? It's the same link which we have been using since day 2 onwards. Only day 1 we had some issue. Is there any confusion? I mean, are you not getting any things? And then how did you join this? I'm a little confused, Doctor. Dr. Parthasarathi, can you please let us know what's the confusion here? We are using the same link for the meeting. Yeah, only day 2, right? Day 2, day 3, day 4, day 5. Tomorrow also we'll use the same link. Okay, I think there's some confusion. If there's any confusion, do let me know. I'll be able to help you guys on that. Okay. Another thing is, Monica says low visibility. Yeah, nothing much I can do, Monica. Madhu, can't help much because this is the best that we can do. Let me see. Uh, no. Yeah. Now is it clear? Now is the font size clear? Okay. All right. Let's proceed further here. Okay. So we are using a function called read underscore CSV. Within the double quotes, you're giving the complete path along with the name of the file and extension. Using the assignment operator, we are assigning it to an object called concrete. And view concrete would actually show this dataset. If I close this and if I type once again here, view in caps, V is in caps, concrete, and click on enter, look at that, it's appearing here. Now I'll show you one more very interesting stuff. And that interesting stuff is, if you have the data like this, I mean, I'll just tell you because it's part of our regular data science training. And that training is for approximately 250 hours. And this training is for maybe, 5 into 2, 10 hours. So there's a huge difference. Okay. Now, if you look at this data set, if you look at age of maybe the concrete, etc., it's in 2 digits. When you look at water, water is in 3 digits. Quartz aggregation is also 3 digits and big numbers. If you have your variables which are of different scales altogether, okay, if you have your variables which are of different scales altogether, then you know what happens? Your model will not work well. When you build your model, it's not going to work well. Your weights will not get updated properly. There are a lot of issues. Your weights will not get updated properly. There are a lot of issues which exist. Hence, Hence, we need to normalize or standardize the data. Okay, you need to normalize or standardize the data. Or let me do one thing. Let me not bother you guys too much with that. Okay, let me just not even apply that, and then without doing that, I'll just split the data into training and test. That should be better. Okay, that's fine. Don't worry too much on that. I mean, given the time limitations, it doesn't make sense. I would otherwise end up confusing you guys on that. All right. So this is something that we have already discussed. And what did we discuss? We discussed that when you have data, you actually need to split the data into training and test. This affirmatively you all remember. Then what we do is we build the model on the training data and we are going to test it on the test data. Okay, we are going to build the model on the training data and we are going to test the data on test data, right? So for that, first we need to split the data into training and test. So what we are doing here is I'm taking rows. I mean, whenever you see these square brackets, it means rows, comma, columns. You're saying that go to concrete dataset, this dataset. Take the rows from 1 to 773 and take all the corresponding columns and assign it to an object called concrete underscore train. Then go to this concrete dataset. Take all the rows from 774 to 1030, all these rows, and take all the corresponding columns and assign it to an object called concrete underscore test. So you're assigning to these two. So you go here. If I click on run, it has created. Look at that, concrete underscore train. So if I click on this, and if I count the number of rows that we have, you have 773. You might ask me this question, hey, why did you take 773? You can take any amount of data, doesn't matter. Why did I take 773? Because I've taken 70% of this data into training. So another 30% will be part of test. Okay, 70% of data is part of training and 30% of data is part of test. So I split that in that way, and 70% of 1030 is this. I mean, that's the thumb rule, generic thumb rule. You can also split the data as 80-20, 90-10, doesn't matter, right? You can try out various proportion of split. Then I'm taking the remaining data, which is from 774 until 1030, all these rows and all the corresponding columns, and then I'm going to assign it to an object called concrete underscore test. Here we go. You have 257 observations and 9 variables. Okay, that's it. Very simple. Now, in order to build any algorithm, uh, there is something called as package in R. What is a package? It is also called as library. Okay, so package or library within R has collection of code. I mean, typically what libraries contain? Books, collection of books. In that way, these packages or libraries have collection of code, collection of programs, which someone else has written in the past. What are we trying to do? We are going to reuse that. If I just neural net, right? Okay. I think we need to install that. Anyways, let me run that. So in order to use any package, you need to first install that. So I'm installing it. Done. Okay. The moment I install, do you see here it's appearing? Because I searched it as neural, it's appearing here. So you could successfully install this neural network algorithm. Okay. Now, if I say library of neural net, when I run this, what it is going to do is it is going to invoke this. Now, to explain this concept of package, I need to go here. Okay. You all are aware of how to install Microsoft Office, right? We all use Word document, PowerPoint, Excel, etc. How do you install it? You go to internet and download the file and install that. Packages are also the same. You need to have internet connection. You need to have internet connection to be able to download and install the package. Okay, the one condition is here, you need internet connection. Wonderful. And to install the package, there is a function in R which is called as install.packages. And within double quotes, you give the name of the package like neural net, nnet, whatever is the name of the package. How would I come to know the package name? Okay, there is no shortcut you have to by heart. There is no shortcut there. You need to by heart. Okay, next. Once you install your Microsoft Office, whenever you want to open your, say, PowerPoint presentation, what do? You just launch the application. You launch the application. The moment, you just double click on the PowerPoint presentation, it's going to launch the application. Here, after you install a package, how do you use that package? You use that package using a function called library. And then you say library of neural net. Library of neural net would actually open this particular package. Okay, you will be able to open the neural net package by running this library of neural net. Any package basically. If you have neural net here, you just type neural net within that and it will invoke. Only then you can use this package or library. So I'll go back here. Hope you all are able to see me. Hear me. Okay. Yeah. CSV means comma separated value. Yes. So here, after you install, you need to invoke. How do you invoke? You just type library of neural net. The moment I run it, see what happens here. There'll be a check mark which will be placed here. See that? There is a check mark which is placed. The moment I run this function line. That means this is active now. This package is active. You can use that. You can use that. So within that, there is something called as neural net. Neural net of formula is y, output variable y, as I've told you, this strength is the output variable and remaining are your input variables. So you're saying y tilde x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7 plus x8. So here you have, let me go to the top. You have x1, x2, x3, x4, x5, x6, x7, x8. And then you have your output variable. Then you are doing y, strength, tilde, all those. And you're taking concrete training dataset. And after you run this algorithm, you're assigning it using assignment operator to an object called concrete underscore model. I'll run this. There we go. We have concrete underscore model. Now if you say plot concrete underscore model, if I run this, look at that. This is a neural network algorithm or the neural network basically. What did I say? How many inputs will you have in your input layer? 1, 2, 3, 4, 5, 6, 7, 8. Why 8? Because you have 8 inputs. Since in your data set you have 8 inputs, you have 8 neurons in your input layer. By default, your algorithm in R takes a single neuron and a single hidden layer. And I also spoke yesterday about a bias. Hey, there'll be 8 inputs and one bias. Bias will always have one. Yep, that's. And these are all the weights. These are all the weights. And that's going to your output neuron. And then finally, output also will have a bias and job done. Here the error is 10967 something something. Can we reduce that error? Sure, you can. Okay, let's see how to reduce the error. Okay, even before that, even before we think about how to reduce the error, let me again go back here and then help you understand this logic that whenever we have data, you need to split that data into training and test. You build your model on the training data and then you test it on the test data. You train it on, you build your model on the training data and test it on the test data. Okay, now we built a model on the training data because if you look at the functions here, we build the model on the training data. Now what do I need to do? I need to compute. I need to compute using this model that we built. We built a model and stored it. I mean, you can give any name. Even you can give your name here. Instead of concrete underscore model, even if you give your name, it doesn't matter. Okay. So what we have done is we have run this algorithm and we stored the results in concrete underscore model. And I'm using this model that we built to compute on the test data. To compute on the test data. Remember, we split that into training and test. Okay, and then the data set that we have is concrete data. We split that into concrete underscore train and concrete underscore test. We built our model on the training data and we need to test it on the test data. When we built a model using the training data, we stored it in an object called as concrete underscore model, right? So we saved the model in an object called concrete underscore model. You can give any name for that case. You can give any name, right? We split the data into training and test. We build the model on the training data and we stored the model in this. Now I'll use this to test on the test data. And if you remember, the actual concrete data had an output variable and 8 input variables: x1, x2, x3, x4, x6, x7, and then x8. When we split the data, we have taken the training data here, and then we have the test data here. So y, x1, x2, x3, x4, x5, x6, x7. So you have output variable and all these inputs: x1, x2, x3, x4, x5, x6, x7, x8. 1, 2, 3, 4, 5, 6. You have an output variable and you have input variables: x1, x2, x3, x4, x5, x6, x7, x8. Okay, you have all of these. And we build the model using this. We want to test it on this. All right. When I want to test it on this, obviously I will say that test on these 1 to 8. If I go here and click on test, 1, 2, 3, 4, 5, 6, 7, 8. 1 until 8 are inputs, and this is your output. So I'll take 1 until 8, and then these are inputs which I'm supplying to the model. So I'm computing using the model that we built on the test data. And when you test it on the test data, you'll get the output variables. Okay, you'll have your output, which is stored here. That output is this one, predict underscore strength. So this model underscore results. Okay, now let me explain this part also very clearly. So when you test, you have taken all these inputs and supplied it to your model. And then you stored the results. That's the predicted values. Remember, when you predict or test on the test data, you'll have predicted values and actual values. Okay. The predicted values are stored here. Predicted underscore strength. Predicted underscore strength. Right. So you're computing using your model on the test data. And then we got the results here. This will have a lot of results, but we are exclusively interested only in this predicted value. So I'm saying go to this model results, pull only the predicted values and store it in an object. There's a predicted value, but where is the actual value? Actual value will be here. This y has all the actual values. You're taking only the inputs and supplying to your model to get the predicted value. Actual values are here in this. Right? Actual values remain in this. That means if we go to concrete underscore test, the strength, this strength, concrete underscore test strength is the actual value. So what I'm going to do now is I'm going to look at, are the predicted values and actual values. So actual values are in concrete underscore test dollar strength. Okay, I'll just say strength. That will have the actual values. So here, when you try to look at the correlation between predicted values and actual values, you get a correlation value. Why? Okay, I didn't run the previous line. Oh, why? Let me see whether I've built it properly or not. Hmm. Oh. Now I got it. Sorry. One part, I think that is, it is mandatory for me to actually Just give me a minute. Network, not sure. Let me try out. Yeah. Just ignore for a moment on what I'm trying to do. Just ignore, please. That's okay. Don't worry too much. Don't worry too much. Okay, about these things. What has happened? I'll just clarify. Yeah, wonderful. Okay. What happened is something that is unimportant for you because there was some portion which I should have included. That's the normalizing bit. That's okay, however. So let's understand the logic here. So what we have done is we have taken this concrete data, we split that into training and test, we build the model, and we tested it on the test data. When we test on the test data, you get the predicted value. That's this. And then you need to compare it with the actual value. In the test data, concrete underscore test, you have this output variable, which is strength. So you're trying to find the correlation between these two, and the correlation happens to be 0.8. Now, say you want to improve the model performance. Say you want to improve the model performance. So what we are doing is we are again building the neural network model. Okay, you're saying y tilde x1 plus x2 plus xt, all of that on the training data. And this time we want to have 5 neurons in the hidden layer. Okay, 5 neurons. Earlier by default, how many neurons were appearing? A single neuron. No, so let me run this. See, this red symbol here means that an operation is currently going on. It's done. Then, if you say plot of concrete underscore model 2, look at that. How many neurons we wanted? 5. 1, 2, 3, 4, 5. It's looking a lot messier. Let me maximize it. Yep. 1, 2, 3, 4, 5. And you'll have 8 in the input. 1, 2, 3, 4, 5, 6, 7, 8. But then each of these will get an additional input called as bias. There'll be another input which is called as bias, which will always have a 1. And then all of those are going to a neuron here, which has another bias. And then finally you have an output. Error is 1.71. It reduced significantly. If you were to look at the first model, look at that, error is 5.02. By default, as I've told you, it will have 1 neuron. But here, look at what has happened. Error also reduced because you had 5 neurons. Of course, it has taken more steps, and this has taken less steps. But then, since you added more neurons, accuracy also should be more. I don't know. Let's see. So what I'm going to do now is, we stored the model. Again, the same thing, friends. We had the data set. Okay, and then what did we do? We split the data into training and test. Here also, when we build the data, we build a model. We are building the model on the training data, right? And storing the model in this concrete model 2. We plotted that, we have seen. Now I'm going to use this model 2 and I'm going to compute on my test data. And when you compute on the test data, you don't want to take everything because you just want your inputs to be given to this model so that you get the predicted values. Predicted values. Now what do? You compare predicted values and actual values by using what? Correlation. So if I say correlation of predicted values comma actual values. Actual values means concrete underscore test dollar the output variable strength. Okay, when we run that model, what would be the correlation value? Here it is 0.8. Here, let me run this. 0.93. Wonderful. So the correlation value also increased. The more the correlation value, more is the relationship between predicted value and actual value. If this correlation coefficient value is higher, that means your predicted and actual values will be, the correlation will be higher. There we go. Okay, so now let me look at your questions. No, they're not similar, Arvind. They're different. Sure, Samya, we shall do that. Okay, all right. So these are hyperparameters, Sri Lakshmi. The number of hidden layers that we have used are hyperparameters. No, actually, Sri Lakshmi, we have dropout, we have drop connect, we have activation functions, we have optimization functions. All these are called as optimizers. It's not possible to complete that in such a short time. Okay, there are many available. Our actual training that I take is for 80 hours. Sri Lakshmi, 80 hours training. I'm trying to compress it here. That's part of our data science training, Sandeep. We have principal component analysis, support singular value decomposition, factor analysis, auto encoders in neural network, all of those. You keep changing it, Sri Lakshmi. There are a lot of algorithms such as grid search techniques, right? Randomized cross validation techniques. You apply those kind of techniques, yeah. But that would mean um, you have to undergo 80 hours of training to be able to have a complete handle of that. Yeah, that's the reason. So here, the best, whatever best we can do, I just try to explain. Now, what I shall do is I shall also open Python and explain. Okay, but what's the time now? Okay, it's exactly 1 hour. So let's take a quick 10 minutes break. It's 3 now, 3:01. Let's come back at 3:10. And then I'm going to run the same thing on Python and then explain you. Okay, let's take a quick break and then be back at 3:10. Hello, are you all back from break? Can you all please confirm? Are you all back from break? Can you all please confirm? Wonderful. So let me now open Python and then we will do this programming on Python also. For that, I've installed something called as Anaconda. All these are funny names, yeah? Anaconda, Python, and all that. But then I'm trying to open Anaconda. Within Anaconda, you can use any of these. All these that you're seeing are called as IDEs, integrated development environments. All these are called as integrated development environments, IDEs. So I'm going to launch Spider. Why Spider? Why not any other thing? It's just that you can choose any of those. I'm choosing this. Oh my God, not again. I think this- when this, let me go to view. I like this R Studio layout, so I'll click on that. Hmm, okay, now. Oh. Hmm. There's something going wrong with this, really, literally. Sorry, once again. Let me close this and then reopen. It usually doesn't behave that way, but then that's okay. That's how it's behaving. So, hmm, view Windows layout, reset to Spider default. Let me reset it and then let me say, hey, I want R Studio layout. Wonderful. Now I think it's fine. Yep. So let's finally I could figure out. Okay. So what we shall do is I'm going to open this data set called as ANN and I'm going to help you solve this MNIST use case. And then alongside, I'm going to explain you in detail on what is it that we are trying to do here. Please pay attention. It's very, very simple. Okay. It is as simple as your English language. So you need not worry much. You need not worry at all because it's as simple as your English language. So just have a look at this. We'll try to make it as simple as possible. And we'll just run this code and understand the program. So if you give me just another minute, I want to take rather a simpler model so that it's easy for you all to understand. Okay, this is MNIST. Yep, it is. So I think this one will be even more simpler. So let me take a simpler code and try to help you guys understand it better. Because this requires some amount of programming knowledge. If you don't have, then it might be slightly complicated. So that's why. All right, now let us understand this code. Within Python also, you have something called as libraries. You have something called as libraries. What is a library? Library is collection of code. Okay, this is collection of code which someone else has written in the past, and we are trying to reuse that. Okay, we are trying to reuse that. And for artificial intelligence, AI, okay, to be built, we have certain libraries, or for deep learning algorithms. Okay, deep learning means neural networks. We have certain libraries such as TensorFlow and Keras. So you have TensorFlow and Keras. TensorFlow is called as high level, or sorry, low level programming language, low level library, or low level programming language. Why is it called as low level programming language? Because you need a lot of programming knowledge to be able to understand the program TensorFlow, the code. Keras is a high level programming language. It runs on top of TensorFlow. If this is your front end, this will be your back end. It sits on top of TensorFlow, Keras. Even a person with no programming knowledge, even a business user, can actually make use of Keras and run deep learning libraries. So here, there is something called as from TensorFlow.keras.datasets, import MNIST, right? You're trying to import MNIST dataset. What is this MNIST dataset? People in the past, they have looked at handwritten digits such as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All these numbers, the moment your algorithm scans this, it should automatically identify that this is 0. It should automatically identify that this is 1. It should automatically identify that this is number 2, number 3, so on and so forth. Handwritten digits. So from TensorFlow Keras datasets, you're trying to import MNIST dataset, which has all these numbers. And when you say MNIST dot load underscore data, MNIST dot load underscore data, it's going to load this MNIST dataset into training and test. It's going to load the data into training and test. Okay, it is automatically going to split the data for you into training data and test data. The only thing it's additionally doing is whenever you have historical data, you'll have output and input, right? And you have to establish the mathematical relationship between y and x. When you split the data, you need both y and x. When you split the data into test data, you once again need both y and x. And when you split the data into y and x, here you're telling train underscore images, train underscore labels, test underscore images, test underscore labels. So you're splitting that automatically. The moment you say load into these, it's automatically doing it for you. So train underscore images is your input, and here train underscore labels is your output. So you're loading. Okay. You're saying from TensorFlow Keras, it has inbuilt datasets. You're trying to import this MNIST dataset. MNIST dataset, as I've told you, contains what? Handwritten digits, such as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? You have 10 numbers. If you say print train underscore images dot number of dimensions. Okay, let me first load this. I didn't load that. We run this. If you say go to the training images and say number, ask for number of dimensions, it says there are 3 dimensions. It's not visible for you, maybe it's saying it is 3 here. Okay, and then you can do various things such as what is the shape and all that, even if you feel that that's not important. Then you can say how many, what is the length of training labels? See, there are how many examples in your training data? 60,000. There are 60,000 in your training data. And when it comes to your test data, how many do you have? Let me run this. Okay, it says you have 10,000 observations of 28 by 28. So you have 10,000 examples which are of size 28 by 28. What does that mean? If I look at number say 2, okay, it has size 28 by 28 and it has 10,000 examples of 28 by 28. That means you'll have 28 rows and 28 columns. That is what it means. Okay, you have 28 rows and 28 columns. And how many do you have? Examples 10,000. Okay, now if I say what is the length of test underscore labels, it's going to say here that there are 10,000. So you have 10,000 in your test, 60,000 in your training. And then you need to build your model. And then we need to build our model. Simple. To build your model here, okay, we are supposed to import certain required packages. So what we are going to do here is we are going to import something called as models and layers, because we need to add one layer after another. Let me add this and then explain on what we are doing here. What we are doing here, let me explain that. Of course, I won't explain all the lines of code. We are going to conduct Python training. I can tell you the dates right away, and the dates are, we are going to conduct on 1st, 2nd, and 3rd. We have manufacturing and automotive analytics session, and the week after that, on 10th, 11th, and 12th, we have Python training, only Python programming. Okay, you might want to join on 10th, 11th, and 12th. It will be exclusive Python training. Okay, all right, let's be back here. So here I'm saying create a sequential model, create a sequential model. And I told that image contains how many rows? 28 rows and 28 columns. So 28 by 28, which is nothing but 784. 784 should be the input. That's what you're saying. So 784 what? Neurons. 1, 2, 3, 4, 5, 6. In that way, how many neurons will you have? You'll have 784 neurons in your input layer. You're going to connect that with the next layer, Okay, let me draw a line instead of that because there are too many, right? 784 neurons, I'll say neurons. You're connecting these 784 neurons to a layer which has 512 neurons. So it will have how many neurons? 512 neurons. Each neuron will be connected to each of the other neuron. Each neuron will be connected to each of the other neuron because we are saying it is dense layer. Remember we discussed dense layer? Dense layer means if you have a network like this, every neuron will be connected to every other neuron. That's called as dense layer. And here when you have your neurons, you also know that neurons have two components, integration and activation. The activation, yesterday we have discussed about step activation, right? On similar lines, there is something called as ReLU activation. And people, once again, this is this is 80 hours training that we deliver on AI and deep learning. Okay, so we are just trying to give you a high level overview. So going step by step and explaining each one because of time constraints that would not be possible. But given the time constraints, I'm trying to do my best. Okay, so please bear with me on that. All right. Next, what we are doing is we are saying network.add, and you're trying to add 10 neurons to this layer. So your output here would have 10 neurons. So you have your input layer, then you have your hidden layer, and then you have your output layer. And then you have your output layer. So you have added a sequential model. You added your dense layer with 512 neurons. So you have your input, which is 28 by 28. You have your dense layer of 512, and then you have another dense layer with 10 neurons. Okay. Next, what we are doing is we are trying to compile the model now. There are three steps. This is called as model specification step. These steps. Okay, not this. The first three. So you specify your model on how many layers you want, how many neurons you want, and all that. The input layer, which is 28 by 28, depends on what is your input data dimension. Simple. Hidden layers, you can put any number of neurons. If you want 512 or 200 or 300 or 1000, that's your wish. And then the next layer is 10, output layer. Okay. So you have your input layer, you have your hidden layer, and then you have your output layer. So input, hidden, and output. In the output layer, you have 10 neurons. Why 10? Because it could be 0 or 1 or 2 or 3 or 4 or until 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 neurons in the output. And you have softmax activation function. Here we have ReLU activation function. Okay. So you have the model specification, and the next thing is model compilation. You have model specification and you have model compilation. As I've told you, we have a lot of optimizer functions, RMS prop, ADAM, ADAGRAD, ADA delta, all that not needed. We have something called as loss, which is categorical. I mean, there are a few questions which people have asked. Loss. Then I need to explain you about loss function, cost function, error function. What is the difference among those three? What is entropy, cross entropy, binary cross entropy, categorical cross entropy, KL divergence? I need to get into all that. That's part of, again, once again, I repeat, it's part of our 80 hours training on exclusive AI. Okay, that's the thing. So at a high level, if you want me to explain, then what we do is we first specify the model, then we compile the model. After specifying the model and compiling the model, forget about these. It's some kind of data pre-processing techniques. Why didn't I run these? Okay, once that is done, what you do is you have to supply your data to your model in a specific format, and then you build your model. You build your model. So what do you do here? You first specify your model. Then what do you do here? You compile your model. Then what do you do here? You train your model. You specify, you compile, and then you train your model. Okay, so what I'm trying to do here is I'll just run this. .fit is going to train your model. Okay, let me train it. See, it's running. It's getting trained. So first of all, we took the data. We split the data into training and test. Then what did we do? Before training the model, there are three steps. Number one, you specify the model, then you compile the model, and then you train the model. Specify, compile, train, three things. Once this is done, then you go back with your trained model and test it on the test data. So you built a model, right? Test it on the test data. Simple. So here I'm saying network.evaluate this model that you built, evaluate on the test data, test labels, test things, and then you run this. And then if I say print the test accuracy, you see the accuracy. If you're not able to see this part, I cannot zoom it, unfortunately. The accuracy value here is 0.9805. That means we could achieve 98% accuracy. Okay, we could achieve 98% accuracy. Are you all there? It'll be slightly complicated. I understand. Thank you. Thank you so much. All right. Okay. Friends, I mean, a few of your questions I'm unable to take at this point of time because there is only so much that we can do in this. It's not a full-blown training, so please bear with me on that. Because we also need to get into image processing stuff. Okay, that's the problem. Okay, so you have the image, and then when the light falls in the image, you'll be able to see the image. This is a very simple image. Whenever you have an image, image is split into pixels. You'll have multiple pixels. Okay. And these pixel values range from 0 to 255. 0 means black, 255 means white. 0 means black, 255 means white. Okay, and if you observe here, this pixel, this is 1, 2, 3, third row, 1, 2, 3, 4, 5, fifth. Third row, 1, 2, 3, 4, 5. It's 0 because it's completely black. The the pixel which is just to the left of this is not completely black, it's gray. So it will have this number. And white, this is white, so you'll have 255. This is also white, so you'll have 255. This is also white, so you'll have 255. This is the first thing that you need to understand about images. That image is ideally unstructured in format. You can bring that into a structured format, and here what we are doing is we are trying to get the pixel intensity values. Okay, we are trying to get pixel intensity values. All right, this is first thing. Second, if you have any image in place, you can actually represent that image in the form of a function. Okay, you can represent the image in the form of a function. And here is a function. In this, you have x-axis, you have y-axis, and you have intensity. Pixel intensity values. And then you plot it in this way. If you look at this function, the values range from 0 to 255. What is this y of x comma y? That's the pixel intensity. So you have x-axis values and you also have y-axis values. You have x and you have y. And all these are the pixel values, intensity values. So you have x, you have y, and you have all the pixel intensity values. Here it is bright, right? It's white. Whenever you have white, you have a peak. Why peak? Because 255 is here at a height. And wherever you have black, so if you look at this complete portion, it is black. So here it is trough. Trough in the sense it's deep there because it's 0. 0 is black. Wherever you have white, say again there is white. So you see that peak there, right? So these intensity values are from 0 to 255. Wherever you see a black, it will be 0, so it will be down there. Wherever it is bright white, it will be 255, and then you'll see a peak like that. So in short, an image, when whatever image you have, those images can be represented as pixel intensity values. It can be represented as pixel intensity values. If you take a color image, you might say, hey, that's black and white or grayscale image. What about a color image? If you take any color image, this color image can also be split into multiple channels. This is called as RGB, red, green, blue color. So you have a red channel, you have a green channel, and then you have a blue channel. You have red, green, and blue, RGB color space. Okay, you have RGB color space, red, green, and blue. Now, each of these red, green, and blue, if you look at that, it appears as if each of these are grayscale images. That is a kind of illusion that I get, right? And once you have an image in place, you can transform the image. Okay, let me ask this question to you guys. If you have x-axis and y-axis here, if I take the input, I mean, this is the image, input image. If I take the input image pixel values, and if I keep adding 20 to that, if I keep adding number 20 to each and every pixel value, if I add 20, what do you think will happen to the output image? What do you think will happen to the output image? Yes, please. Can you all please respond to this? What happened? Yeah. Please, can you respond to it? Okay, let me ask this question. A lot of you all are again saying that you're not able to hear me and all that. So let me take a quick poll. Are you able to hear me? Yes or a no? Please, can you all respond to this? Ninety percent of them are able to hear me. Remaining 6% of people, you have internet issues at your end. Okay, you have some speaker issues at your end. So I request you all to fix the issues at your end, because I keep seeing that message, that continuously voices breaking and all that. That's because there is some internet issue at your end, friends. Okay, so let me quickly also mention that 95% of people are able to hear me. Other people, please check your internet. And also, please check your audio, such as speakers or anything that you have, headphones, etc. Yeah, please check that. Please restart. Please rejoin, because if you keep putting those messages, I don't usually check at each and every message because I need to focus on the training also. So you might miss out on certain things. Yeah, this is a humble request. Please do this. All right, so we have less time. Let's move on. I saw your responses and then I'm really impressed. I'm really impressed. Okay. That absolutely, you told it right, that if I take each pixel value, I already know that pixel values range from 0 to 255. 0 means black, 255 means white. Okay, and then when I split this into pixels, okay, and if I take each of those pixel values, if I take each of those pixel values and if I add 20 to that, if I take each pixel value and if I add 20 to it, then you get an output image, which, I mean, if I take each pixel and keep adding 20, all the pixel values will slightly be moving towards white, right? Because you're adding some additional number. Even if you have 0 and if you are 20, it becomes 20. That means you are moving towards white. It's not black anymore. You are moving towards white. So your resultant image or the output image will become bright because it's moving. All the pixels you are moving there. So it will become bright like this. Now question to you. If already there is a white pixel, say this pixel value is already 255, assume. And on top of that, if you add 20, it becomes 275, right? But then what happens is this value is reset. This value is reset to 255 because the maximum that your pixel values can take is 255. Since the maximum that your pixel values can take is 255, right? You get that 255. Even if you have a bigger number, it will get reset to 255. What if I do this transformation? I take the input image and I put minus x instead of x. Then what will happen to the output image? Yep. Please, can you respond? Let's see who will get it right. What do you think will happen here? Okay. So let's see. Mirror image. Absolutely. Absolutely. That's a mirror image. You all are right. So what will happen is, see, friends, let me explain. This is how your quadrant will look like, right? X-axis and y-axis. Here you'll have your origin 0, 0. And here you'll have x values. X is equal to 1, 2, 3, 4, 5 in that way. And on this side, you'll have all the positive values. On this side, you'll have all negative values, -1, -2, -3, and all that. And here you'll have all the positive y values. Okay, and here you'll have all the y negative values. And then this image is like this. This is the image. And all I'm saying is if I have my y remain as is, this y-axis as is, and if I change x to -x, so all these positive values will have negative values here. Okay, all these positive, you're making it negative. If it's 1, you're making it -1, -x, right? If x values are say 1, 2, 3, 4, 5, when you say -x, what is it that you're doing? -1, -2, -3, -4, and -5. So you're taking all these negative values. So this image goes on this side. You have an image on the positive side. You're taking a flip of that, and that's your negative side. That's how it gets flipped. And then missing operations. All these are fine. Now, what I want to do is, I will quickly, rather than bother you with this, I will quickly open the computer vision part and then help you understand on how to read a file and how to, do certain transformations on that. I'll not get into the depth of this, but then a few things. For you to be able to use image processing within Python, you have something called as OpenCV. Okay, we have something called as OpenCV. OpenCV stands for computer vision. Open computer vision. You can perform your computer vision activities when it comes to Python, basically, right? So, how do you read a file? How do you read a file? So, first thing is you need to import OpenCV. It's CV2. That's how it's named, computer vision. So, I'll import that. Once you import, within the CV2, there is a function called as image read. Okay, so image read. So you're going to read the image using the CV2, and within the brackets, you provide the complete path of the image along with the image and the extension. And you're assigning it to an object called img image. What is the dimension of the image? Dimension of the image is 256 by 256. That means you have 256 rows and you have 256 columns. And you have three. Three means it's a color image. Okay, three means it's a color image. One means if you would have had one here, that would be grayscale image. Okay, one means grayscale image. So you're reading your file image and you're saying cv2.image show the image. Which image do you want to show? This image, img. And you want to give the name to that window as input image. Forget about this wait key. For now, forget about the wait key. That's part of our other algorithm. Look at that. So this is the image that we have read. Okay, that's a mandrill, mammal basically, like monkey. So you have loaded this. Now, if you want, you need to press escape. Okay, if you press escape, then that's gone. Next, same. You need not again and again import, but I've just given it for that clarity. After you read the image, if you say cv2 dot image read underscore grayscale, means even if it is a color image, if you load that color image, you want that to automatically get converted to a grayscale. Then if you run this, you would be able to see the grayscale image. So let me show. There we go. Look at that. This is a grayscale image. Right? Earlier you had a color image, but then you wanted that to be in a grayscale image. Okay, and then a few things I'm purposefully skipping, friends, because that's not needed. All right, then you can take that particular image and there is something called as convert the color space. You have RGB color space. There is something called as YUV color space. Okay, there is something called as CYMK color space, HSV color space. There are many color spaces. How to give a color to your image? Multiple ways of giving. Okay, so forget about that now. So you're converting this color image into from blue, green, red, RGB or blue, green, red to YUV, a different color space. And you're storing that in this YUV underscore image. Now, if I say CV2 dot split, if I say CV2 dot split of this image, and if I run this, it's going to give Y U, and V. All the three. Can we view each channel? Oh, yes. Let's view. Image show the Y channel, U channel, and V channel. Let me run this. There you go. You have the Y channel, you have the U channel, and then you have the V channel. Y, U, V. In this way, you can play around with your images. And if it's in color format or grayscale format, this is how it would be. And then what you're doing is you're taking your image and then you're splitting those into red channel, Y, U, and V. Even if you split the image into, say, if you take a color image like this, yeah, we are taking this color image only and then we are splitting it. If you split this into RGB, red, green, and blue, still it's the same. I mean, you can split it. I think I've shown here, right? RGB, and then you can view R channel, U channel, and blue channel. Let me show you that also. Or that's fine. I think I have shown it to you guys here. That when you have an image, and if the image is in color, when you split it into R, G, and B, this is how it gets splitted, friends. Right? You will feel as if that's a grayscale image. You'll feel as if it's a grayscale image, basically. Okay. So these are the kind of interesting things that one can perform using OpenCV. So I'll just stop here and then, yeah, that's how it is. Because, okay, there's a question. Why is this red appearing as gray color? Okay, there is something called as RGB. Okay, RGB color space. When you look at your RGB color space, when I click on that, okay, this is RGB color space and it's called as additive model, not mistaken. Same thing is coming up. Let me see. Yeah. So what happens is when you see this RGB, right, you actually project that on some black surface or a white surface. And then when you keep combining different colors, you'll be able to see different colors. But when I want to extract only the red or green or blue, it won't look like red color. It's some color which is going to look like gray. Only because there is combination of different colors, you're able to see that color. Okay, you have additive channels, then you have subtractive channels, all that. So there are many, many other things. Okay. Okay, that's a different story, discussion. I'll stop here. Enoch, are you there? Enoch, by any chance? Yeah.
I'm here.
Enoch, a few of our people have asked for feedback forms. Attendance
Okay.
forms, don't worry, friends. Okay. And feedback forms, you might want to give it to them. And then feedback in the sense the same Google part or Facebook, whatever our participants have, and then we can take it further.
Yeah.
Yeah. Sure. So over to you. You might want to share the screen and then please quickly.
I'll do that.
Share. Yeah. Yeah, there are a lot of questions, that you're asking. CYMK, yes, it's subtractive model. RGB is additive model. For radars, no, Sasita. Radar is really different. It's used in autonomous vehicles nowadays to a very great extent. How can we recognize RGB channel? You just split it. It will give you red, green, and blue channels, Sasita. Okay. There will be slight difference if you see these channels, right? Y, V, and U. There is slight difference. In that way, you can just give a name, heading, so that you understand that it's red channel, green channel, and blue channel, right? Yeah, we will tell you how we are going to view presentations, because all these presentations are slightly our own intellectual property kind of, but we will see what best can we do. Yeah, over to you, Enoch. You might want to share your screen.
Thank you, Bharat. So guys, I've shared a link on the top. So I'm even gonna share the link in the comment section. So all you need to do is go to the top section here where it says review and click on the link. And once you click on the link, it will open the Google Maps along with the section where you can give your review. Since I've already given my review, it is asking me to edit my review. If at all you were doing this for the first time, it would say write your review. So all you need to do is click on it, and right after that, it would ask you to give a rating. So within this section, you can give your rating. If you like the training, you could give the 5-star rating. And after that, you need to give a comment right underneath that. Don't just give a rating and leave it there. Please write a few sentences. Even if it's just 2 sentences, that's still fine, but please write something. So write a couple of sentences, review, and then click on post. And it should automatically be added to the list here. There you go. So for those of you who have missed the URL, I'm gonna paste it once again in the chat. And all you need to do is click this link, come here, click on give your review, and select the rating, write a couple of sentences about a couple of sentences feedback, and then click on post. And that's it, guys. This is how you can give your feedback. If you've already given, that's fine. This is for those of you who have not given yet. So if you've already given, then nothing to worry. It's pretty straightforward. And review is one thing. And apart from that, for those of you who have not yet joined our Facebook group, I am going to share the link to it right here. Within the sticky note, there is a link, and also in the chat. So this is where we will be constantly posting about our new programs. And this is like a community where you can ask questions, get answers, or get inspirations, get the latest news, what's happening in the data science space or the AI space. So this will basically give you all the latest information within the group. And also it is interactive, it is a community driven. So you can connect with a lot of other data scientists within the group. And that is one. And then for those of you who wanted the recordings, I am sharing the link for the recordings now. It should be on a sticky note. And this is where we have all the recorded sessions. So if you click and go to the link, you will see our day 2 and day 3 videos here. Day 2 and day 3. So today's video will be uploaded most probably by today evening. And it is the same link, guys. It is the very same link. And you can just access the sessions here. Hardesh Kaur, there you go. That's for you. And that's about it, guys. Thank you so much. Have a good evening. Bye-bye. Dr. Jayaraman, we had some technical difficulties with the platform for day 1 videos. So we are in conversation with the platform trying to get it. So if all goes well, we will have the video with us. So fingers crossed. Yeah. Thank you, guys.